B2. Yep, that's the one I think I needed. Right, I think we're here, and here we go. Yes, Peter, here we go for another night of fun and what's the other word?
Fusion.
We can sit around scratching our head trying to think of something. Ah, that'd be right. I go to sit down, and I forget something that I was supposed to get before I sat down. So I'll just grab it while I'm here. Um, that video we're going to play. That video we're going to play. So is it going to win any awards?
Maybe awards for stupidity.
Okay.
I don't know if it's the DFOTY material, but
Well, we do
it's
have
certainly not right.
we do have the FDDA awards, Mark. Don't you remember them, or did you miss that memo?
I may have missed it.
It's the Fair Dinkum Drongo Award. I've been compiling
a little bit of an Aussie spin on it.
Yeah, with an Aussie spin on it. Yeah. So it might not be in the same caliber as that other one, the other award, but we'll do our own take. We're doing our own take on it. I've been collecting a few. I think we met one the other week, but it's the what's the word for it? It's the type of derp flirt, what they are for stupid, for what we want to put them in for that award. Because I think the award for what they use for that other one, I keep forgetting the name of it. It's a different level. Like they got the Rileys and the Oakleys and all them people.
Thompson,
yeah. So that's on a different level. We're going to have to find the ones that are actually drongos, as we categorise what a drongo is.
I think this guy probably qualifies.
All right. Okay. We got it here ready. Need sound. Share. Here we go. And as Blue would say, push your thing back and have your mitts ready and stuff.
All right. So, previously we've discussed conspiracies and the flat earth. And people have they've questioned it. They said, "Where's the proof?" Well, I got the proof today for $1. $1. $1, ladies and gentlemen, and I have the proof that the Earth is flat. Where's the proof, you say? Well, right here. See this? This is flat, and this is a dome over the Earth. The Earth is flat, and this is a dome. Okay? It's round. You can't see the round, but it's round and flat, covered in a dome. And look here. This is the moon. Look. Flat. 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 Flat Earth. Flat Moon. I proved the whole thing. And it only cost $1.
Right,
There you
pause
have it,
Terry,
ladies and
pause.
gentlemen. Proof
This has got to
The
be a troll,
Earth
though, right? Seriously.
is indeed flat.
Right, there you go. It raises a lot of questions, though, doesn't it? Because, like, okay, if that's the flat Earth and that's the dome, how did they get?
How do you get out of it?
Yeah, how did they get there to take that picture?
And
To be fair, I thought he was going to go in a different direction with this.
yeah, I did too. But when he was saying the Earth's flat and that's the dome, and then he pointed to the moon, and I went, "Hey, wait a minute! How'd the moon get all the way out here? That's a different one again." Okay.
I've never seen that argument before. You obviously have to acknowledge the existence of space for this.
Yes,
this,
that's true.
Indeed,
this thing to work.
Mm-hmm.
I was halfway expecting him to just sort of, tilt it and go, see, it's flat.
Well, it's on a flat frame, yeah, flat paper.
Yeah.
But for $1,
Must be flat.
well, you have to take in inflation and currency exchange and all that sort of stuff too. So, did it actually cost him $1? Oh. Okay.
At least what he paid for it really does, match the quality level of the argument.
I don't think I can beat that. I don't even think it's worth debunking. It's just it's out there. Well, out there when they took the shot, but thanks for that.
Yeah, I thought that was a good one.
Such
New
a
argument.
compelling new argument.
Now we just wasted 2 minutes. We'll find some more. We can waste some more minutes on. Well, I don't know of any other. I haven't had any looking to see what other dirt we've got. So I don't really want to go down the same road. I know Lindsay Harris has uploaded another one again. Flat Earth Design shows science how it works. We're still going to go back to catch up on his original concepts. Because I'm trying to work out why he's got these two dome-shaped objects in his drawings all the time.
That's the cross-section of the torus that surrounds the center of the Earth. That's what that is, and it's that apparently it's the magnetic field of that torus that creates the vortex in the middle that seems to be responsible for everything. You get it? Like if you cut a donut in half, you'd get those two dome sort of things.
Cut a donut in half, you get two little horseshoe-shaped
sort of like
things.
Yeah, if you look at it from the side, that's what he's sort of like thinking like.
No, I still can't picture it. I think that one's going to have to be. that's just too hard to even get my brain around it. Trying to work it out even. I think it'd break me brain even trying for that one.
I think we're talking more of a cross section, yeah?
Yeah, that's right.
Well, I got a picture of it here, if that helps you. There you go. That's what you're talking about. Yeah, his latest videos got the two dome-shaped things. I know he was talking about this bit in the middle, but I'm trying to work out in a better representation of what he means. Not so much in a verbal.
Now have a look at that picture that he's got on the right-hand side of his whiteboard there, looking down on top. That's what he sees looking down on top of the torus. Okay, you know what a torus is? It's a donut sort of shape, except this one's only got a very small hole in the center. Okay, so now if you do it, slice down vertically through that, and then turn it on
I
its
get
side
it.
and look at
Yeah,
it like a
now I
cross
get it.
section, you get it now?
Now I
Yeah,
get it. Now I
yeah,
get it.
yeah,
Okay, so it's a donut with a vortex shape, um,
yeah,
funnel shape in the middle. Yeah.
yes, yeah. You got it
Okay.
now. And
Okay.
somehow magically that vortex does things.
Well, we could either watch his last one. Pip's saying no, Terry, not Lindsay. Well, people that say no, people that say no to what I want to play have to give me an alternative derp video.
Alternatives.
Yep, that's it.
I did, but apparently it wasn't long enough.
You tried, you tried, you tried.
Yeah. Can't we just play that one 5 times?
I can always play it again. Just put it on repeat. No, you don't often see those ones like that. That's the first time I've seen that one. That's the most original of them. I know it doesn't explain why the moon's out in space, but he's saying it because we see that if there was space. Yeah.
And his domes don't look anything like the dome in the Flat Earth proof video we just watched. So
No,
obviously this
no.
one's fake.
He's hard enough to understand at normal speed. What? Oh, Pip's saying because he can't understand Australian English. Doris, okay, you're going to vote for Dora to play his latest one. Thank God it's flat said, even I don't understand him. Thank you, thank God it's flat. So I've got one for I don't understand, a vote for a no, but no alternative. Yeah, that's what I thought. He's sort of got a very, very faint Kiwi twang to some of his words.
You're talking about me again.
Who? You? No, you. I don't really pick up on any of your twang.
It's because I'm a North Islander, not a Southerner.
There is a difference. Okay. Fair enough.
Big difference.
Oh.
Yeah, the North doesn't have fush and chops.
And you haven't got any decks.
Oh, we have decks.
Oh, okay. Do you use cork on your decks?
Sometimes caulk them, yeah.
I heard black cork's best.
I prefer to wax my deck.
Okay. Have you had many people on your deck?
Oh, plenty. Big parties on my deck. Been a while though.
I've still got that video for that ad somewhere laying around. I'll have to play it again one day. So we can either go back. I'd like to go back into his videos, not so much his latest for that guy, for that Lindsay guy, because I'd like to see where he's been to where he's got to now. Renee and me saying 4. I don't think that counts over on Alan's channel for Renee and me. So if I've got no other alternatives, videos sort by oldest. Okay. Oh, Star Trail, 15th of the 3rd, 2020, New Zealand. That's a clue. That's on his, and he's got Star Trail facing north from Auckland, New Zealand. I think we might be onto something here.
Star Trail's facing north from Auckland. That'd be interesting.
Yeah, Star Trail's facing north from Auckland, New Zealand. He's got that one. And he's got a Star Trail northeast, a Star Trail northwest. Wow. Star Trail south from New Zealand. So he's obviously figuring that out. But that doesn't mean anything, I suppose. That one goes for. Ooh, that goes for 17 minutes. You don't want 17 minutes of him rambling on, I suppose. Oh, 22, 24, 23. Shit. I think we might have to split one up. We'll play. If we play the long ones, we'll just go halves in it because we played 17 minutes of that one last time. The next one is 17 minutes. Flat Earth with ancient Egyptian, ancient Egypt, esoteric knowledge from the ancient Egyptian, the Avatar tree via ancient Egyptian. Okay, so he's getting into those things. Secrets of the Egyptian Sphinx. Oh, okay, the true flat Earth model. Here we go. How about that one? That's his flat Earth one. So we'll stick with that. The other stuff's just ancient Egypt stuff and everything. So we'll split this up if we run out of time, or if anyone's brain starts hurting. I need new material for a pippy quickie. Well, I'm not going to touch that one. Oh, it's Phil out in the peanut gallery, is he? Somebody's mentioned Phil. I know he was over in Gems earlier.
Let's have another go at the flat Earth. The ultimate design of our flat Earth. It's all there. Cannot be debunked. Fact. Someone needs to prove it. All I can do is prove it with what the ancient Egyptians have left us. Nature, magnetism, religion. All religion is all related to this. So here we have it. The centre-north vortex. Hyperpoloid in the magnetic field. Imagine a magnet there. Magnetic centripetal divergence. Divergence. It swings back around and up and behind. It's convergence coming back in, sending the flow up.
Magnetic centripetal divergence? What the hell is that?
Word
Let's
salad.
just jam some words together and
I
pretend
think
like
so.
it means something.
Yeah. That would have made Lemonbird proud, that combination.
Yep. I'd like to see his explanation as to why what I'm going to go with there's field lines in that plan view.
Oh, was I
Yeah.
muted? Was I muted?
Cool
Sorry.
to hell.
You were.
Yes, you were.
Oh, okay. Oh, you didn't hear my stupid question then.
What was your stupid question?
Where do we live on this donut?
Underneath it, on that line that's going through the middle, I would assume.
Well, we're inside it.
Yeah.
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 Yeah, that's the central. I'm going to use vortex, but God only knows what he thinks it is. Is touches down and converges at the North Pole. That's my guess.
Yeah.
Oh, that's weird. So where's the South Pole?
So the horizontal line is the South Pole doesn't exist. It's the southern ring.
That's even worse.
I know.
That's even worse than I thought.
So magnetism works. We have this
That's
design
not
here
how
of the magnetic
magnetism
fields
works.
going up to the equator. Celestial equator, where the sun area is, sun is.
What?
So that's the magnetic fields go up to support the sun, I guess.
Oh, so
I don't know.
he drew a circle where the sun is. So what's the? And he said the equator. Well, the equator runs
Yeah,
down.
The equator will be directly underneath that.
Yeah. Remember how on the circle on the flat Earth disk, the equator is somewhere between the center and the edge?
Yeah.
Well, that sun is directly above the equator. He's saying that the equator is where the top of the toroidal magnetic field is.
So these dome oh shit. I don't even want to ask the questions.
It's looking more and more like boobs all the time.
Yeah. They're not domes, Terry. They're what they are. It's supposed to be some sort of toroidal magnetic field.
Oh, so it's not a physical structural.
No, I don't think so.
That's why I'm trying to work out where the solid part is. Like, that's the part I'm trying to figure out. I know he's got these lines running around, field lines and all that sort of stuff, but in the sun, yeah, okay, I'll keep going. Maybe it doesn't matter.
Pulsate of the Earth, back to the sun. Negative, neutrons, electrons, up to the proton.
What?
Positive.
Negative neutrons.
Sun.
Hey?
Did he just say
neutrons.
negative neutrons?
Yeah, I
Yep.
thought he said negative
Oh,
neutrons
dear.
in the same sentence.
Yeah, he did. And then he corrected himself.
He did correct himself, and electrons are in fact negative, so, you know,
Yeah,
at least
yeah.
he's better than most flatties.
Okay.
All the stars, all the constellations are all in here.
What about the ones on the outside?
Yeah,
What
that's
about the southern ones?
Yeah, what about the ones that are past the equator?
What about all the rest?
Yeah.
Wait, maybe there's some kind of, magnetic light bending going on.
well. He did his star trials in his video, so the ones he did facing south or facing north. I have to see if he actually narrates any explanation for this to see, because it might tie together.
Egyptian myth tells us you cannot see it. You cannot see the heart of the king. But it is for a king to search out the matter. It's all in there, all reflected up. All reflected up on the night sky dome.
Oh,
And this
wait a minute,
There's a
in
dome
here
over this.
He just drew a dome over the whole lot.
Yeah, he did. Yeah.
Okay. I think I'm getting it now. Oh shit! Did I just say that?
That's all right. We can probably medicate for that.
Yeah, we can fix that, Terry.
Okay.
is reflected out to the south. So what we see is basically...
Just pause it
You see the
for a
moon?
moment there, Terry. He keeps on saying reflected out. Does he understand what the concept of reflection is? That you've got to have something to reflect off of?
Hmm.
I mean, what's causing this reflection?
Well, he just talked about the starlight proceeding upwards to the dome, so I presume he means that it's reflecting off the dome.
Yeah, but he's saying it's reflected outwards now. He's saying that some things are reflected outwards to this point out here that he's pointing at right now. That's what I thought he said, that it was being reflected outwards. He's saying some things are reflected upwards and some are reflected outwards, but he's never actually identified any surface or anything that it's being reflected from.
There you are. And this is what it was in here, is reflected out. Isn't it something projected or emitted or not reflect? Yeah, because reflected is.
I mean, he's just drawing, like he says, all the stars are in the center here, and then he's just moving his hand across to where they're being reflected to, but he's not actually showing any reflection in his diagrams, if you get what I mean.
I'd like to see some reflection lines.
Yeah.
Yeah, that's where he
Like
starts.
to see some geometric optics being done here.
Yeah.
So after this, he says it.
It's all in there, all reflected up.
Yeah, all reflected up.
Yeah, so he just sort of moves his hand in the upwards direction and says it's all being reflected up, but he doesn't actually indicate what it's being reflected from or how this reflection is happening in any way.
I don't think he understands what the word reflected means.
Reflected up on the night sky dome. And this, whatever's in here, is reflected out to the south. So what we see
Again, reflected
is
by what?
basically,
Yeah.
if you see the moon or the sun out here, it's a hologram, basically.
Oh,
What?
it's called a hologram. And again, I don't think these people that say things are holograms understand what's required to actually make a hologram. You know, you can get holograms that are reflected off of imprinted surfaces, like shiny things, or you can get light holograms where you use a reference beam and the light coming from the objects themselves. They interfere, causing a interference pattern on the photographic plate, and then when you shine the reference beam back through that photographic plate, you create the image. But to do that, you've got to actually make the photographic plate with the interference pattern on it to produce the hologram, and you've got to shine a laser through that to produce the hologram. They use this word hologram like a magical fix-all that, oh, there's something we can't explain, let's call it a hologram.
I think there's this thing you can buy. You put something inside of it, and it's got interestingly curved, I think possibly parabolic mirrors in it. And it makes it look like the thing that's put inside is actually hovering above it. That's not a hologram, but that's the sort of thing that I feel like he's talking about.
Yeah, maybe.
It's a reflection of
But
what's
the important part there is what actually is the moon. You've got to have something to be reflected, right?
Yeah,
so the
that's
moon's
right.
got to be somewhere.
Yeah, because a hologram has to be, something has to be emitting something from somewhere for it to make it a hologram, yeah.
It's all reflections of Aristarchus.
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 Concave mirror.
The pirate.
Obsidian.
What? What? Concave mirror? So the dome's the mirror.
Yeah,
Glass.
he's talking about that effect that I was talking about with the concave mirrors set up just the right way so that you can have a thing look like it's somewhere it's not.
Yeah. Well, I have
The
heard that
important part
argument
is
before about that.
those mirrors are not, they're not the same as a dome. The dome would have to be a really interestingly contorted, let me say contorted because it's better than the F word, contorted shape, and none of them claim that it is.
So obsidian
But then
glass.
none of them have an idea about optics anyway.
So what's obsidian glass? Is that real?
Yeah.
Because it can't be
is.
real because
Yeah.
it's all fantasy, this glass stuff, so it can't be a man-made object. It has to be some other supernatural unknown.
Well, obsidian is a metamorphic volcanic rock.
Right.
You know, it's that black glass-like rock that you get.
Oh, that's why the sky's black at night, right?
Oh, yeah, it is too.
Yeah.
That answers that question.
Possibly. But there is a solid dome and it's reflective. It's reflective. What have the ancient Egyptians left us? Consider it all myths swept under the mat. He's supporting the sky. That is supporting the night sky. See that? Another drawing. Night sky. Astronomy. They know it's flat up here. What's she doing? Looking back this way. She's looking back because it's reflected back.
How does someone take drawings that were done back then, which there have been a lot of them, and then 100% go, yep, that's what it is, from the way they knew things and how they interpreted what their reality back then. That's what I can't understand with that part of it.
Because ancient cultures obviously know more than we do, somehow. It's all lost knowledge.
Oh, the lost knowledge. Oh, I was going to say that's
Like,
another
we
thing.
couldn't build the pyramids. Okay, we could, but
Yeah,
we
yeah.
couldn't
I
build
know
the
what you mean.
pyramids.
Yeah, we couldn't. Yeah, there was an advanced technology. That's the same with the mines and NASCAR lines and all that sort of stuff.
Yeah.
Ancient technologies that we couldn't do.
NASCAR lines, do they always turn left?
I thought they were called the NASCAR lines or something.
Yeah, just without the R on the end.
Oh, okay.
NAZCA or something like that.
Oh, okay.
And just while we're on pronunciation, I'm pretty sure he's a South African, not a Kiwi.
Oh, that throws a different spanner in the works for what I was thinking then. Yeah, okay.
Just saying.
Okay.
He
Well, we've
doesn't
got a
sound
South
like me.
African here. We've got a Carl. he can verify that.
Arrow pointed this way. Showing the picture that way. She's reflecting it back, possibly. All these different elevations. This plasma field. The sun sits in,
Nope, that's not so.
Plasma
Yeah.
field,
And
yeah.
this is an export.
moves in and out.
Export. Good one, Carl.
This is where we get the sun way out here in the south in Antarctica.
We export a lot.
Oh, Antarctica's out there. Oh, so we're on the edge of the dome like we are on the edge of a flat Earth then. So we're looking at it,
Yeah.
the straight line that goes horizontal through the middle bit
Yeah.
is as in the plane.
Yep.
Okay, and
Yep.
then the Antarctica's out there where his hand is. Right.
Yeah, he's
Okay.
saying that the reflections from the dome explain why you can see the sun in Antarctica.
Okay.
Let's ignore the fact that you should be able to then see two suns because you'd have a straight line of sight to where he thinks the sun actually is.
Yeah.
Okay, I'll get to,
And it,
I have to explain that, why we don't see two suns. Or two moons.
It's reflected out there. It's not down there. There's nothing actually in here. It's reflected. So this is magnetism. This is where everything began on the flat earth and grew out. This is Genesis. In the Bible we speak of Genesis. And what do we have? The tree of life. The tree of life. Because everything in all those stars and celestial bodies create life down here on earth. What is below is what is above. So below, so above. So the
It's got the celestial bodies in the middle section. That's, and then he's
I
saying
have
things get
never seen a
reflected.
tree that looks like that.
no.
So in his mind, when we look south towards the dome, towards Antarctica, we're only seeing a reflection of the stars that are in the middle bit.
Yeah, that's what he keeps saying.
Yeah.
But he doesn't actually identify any mechanism that's reflecting it out there, other than a bit of a hand wave every now and then. That's what. Have you noticed that whenever he talks about reflection or something being reflected out there, he just waves his hand over it a bit, and that's the explanation.
Okay.
energy down here creates this flow to the top, and in return that creates life on earth. That's how it works. You cannot see anything in here until it's reflected on the dome.
Even if that were true, that would be what it does, not how it does.
Yeah, that's right.
How
Did
does
you
it
get-
do this?
Yeah, did you get the hand waving? The
Yes.
explanation by just waving his hand over it a bit. That's the explanation.
Right. Okay.
Yeah, I've literally never seen this much hand waving.
Yeah. You sure he's not Italian?
Actually, had an Italian teacher who didn't hand wave this much.
Okay.
Fruit from the centre of the garden, do not eat it, lest you will die. Do not eat from the fruit of the tree in the centre of the garden. Meaning, this is to do with enlightenment. It's the moon, the magnetic force of the moon on the human brain. It's rebirth, reborn, spiritual awakening, a religious thing. But it's all represented in here. It's everything that's in here. It's related
sorry.
to man.
I'm sorry, does he even have any clue how weak the moon's magnetic field is? Oh my god.
Yeah, I know. And what's he saying? The magnetic field of enlightenment on the human brain.
Yeah, that's the
Is he
food.
trying to say?
Since when is
Yeah.
enlightenment magnetic? Come on.
Yeah. Is he saying that if we stand in the moonlight, we'll get smart?
Ooh.
No, we'll be changed.
Ooh.
Oh.
Ooh.
Or we'll understand morality or something. I don't know. He's talking about the friggin'
Yeah.
Genesis story.
I think he might have been standing out in the sun too much.
To life, everything. Hades, Egyptian mythology is called Hades. Down into the underworld.
What?
And the story in Hades is Persephone and Demeter. Demeter, the night sky. Persephone, her daughter, who represents spring, that rises and goes back down into the.
That doesn't make any correlation at all.
underworld.
Those
It
words.
comes up when it's springtime, up and down. Read the story. It's describing it.
Yeah.
It's Greek
Another
mythology,
myth,
Terry.
Oh,
The
okay.
lion is to do with the moon. Heracles or Hercules dealing to the moon, going out to slaughter the moon, but that's to do with the full solar eclipse, and it's in relation to the Sphinx, what the Sphinx is looking at between Virgo and Leo. It's all to do with the full moon
He's all over the place.
following
Yeah.
the full solar eclipse.
He's trying to
He's
trying
trying
to interpret the Greek mythology like you're saying, but I
Every
don't.
mythology.
Yeah, he's got Egyptian mythology in there. He's using the Greeks and
The Christians?
yeah.
Yeah.
This is what happens when you get dementia, folks.
Go on, mention Marduk. I dare you.
But I just hope we have a whiteboard when we do.
Silvering the moon. If you realise it's the moon he's cutting up, I'll try and show that later, you'll understand the whole story. Because the moon's overlaying
I like the text. You don't understand the whole story.
the sun, the full solar eclipse. It has to do with the pelt and the claw, the pelt, peeling off his pelt, because the moon does not have a pelt when it's in new moon for the solar eclipse. For the full solar eclipse, you do not see the moon, do you? It does not have the skin. And then the claw is represented by the crescent of the moon. It looks like a lion's claw. You relate that? I'll try and get onto that later.
What?
You can still see the moon in
crescent-
a solar eclipse.
The crescent of the moon doesn't look anything like a lion's claw. I think he's got a very vivid imagination.
Yeah. Where?
But they're both curved, man.
Ah. I mean, it's yeah. I mean, I'm sorry, it's obvious, isn't it? When I look at a lion's foot, I think, oh, there's the moon.
See, in a solar eclipse, you don't see the moon. What does the
Because
moon?
it
Where does
doesn't
the
have
moon
its
go?
skin on.
Oh, okay, because it doesn't have the skin. Oh, is that why? I missed that bit. Sorry.
And then the claw is represented by the crescent of the moon. It looks like a lion's claw. You relate
Yeah.
that?
Sure.
I'll try and get onto that later. Phoenix rising out of the ashes. This is our flat Earth. These are the magnetic fields that come out of the south. This is how it works.
Well, that doesn't help with the compass. If they're meant to be magnetic field lines, how would you know which way north would be? Or south?
Well, north is towards the middle and south is away from the middle, right? But he's talking about it like the field lines follow the outside of this toroidal structure.
But how's he
And
explain?
I'm just failing to see any sense in it.
Yeah.
I'd like to know what mechanism is generating that magnetic field.
Well, yeah, he hasn't actually mentioned that.
It's called
And this
God.
And these are one
Yeah.
of his first videos, so he hasn't mentioned it in the first one.
This is nature, isn't it? You've seen that? The
What?
fields come out to the equator.
He's drawn
There's the
south
equator.
south.
Comes out of the south to the equator. Out of centre north to the equator. Out of centre north to the equator. Where it pulsates the earth.
Pause.
Why is he
Pause.
going?
Pause.
What?
Convention in magnetic fields tell you that they don't go out of both poles. The magnetic field lines go into one pole and out of
the
another
other.
by
Yeah.
convention. Yeah. So how can they be coming out of both poles?
I've never seen that.
I mean, to be fair, you could look at this like it was a tokamak or something where the field is toroidal.
Yeah.
But
that still wouldn't
there needs to
result
be a
in the
mechanism.
field lines coming out of both
No.
south and the
No,
north,
it
would
wouldn't.
it?
I'm just trying to visualize what the hell he's on and wondering
aren't
what kind
we
of
all?
meds he needs.
I think I'm visualizing more of what he's not on.
Yeah.
He has failed to take his medication.
Yeah. Must be that
And
time
this is
of
the
day.
result. Yeah.
It's the flow, perpetual energy. Infinite sign, the snake.
Oh, there you go. It's perpetual energy.
There you go. Yeah, but he threw the
Because
snake.
it looks kind of like an infinity symbol.
And the
Something
snake.
that men created many thousands of years ago, but post-dates the start of the universe by a long time, no matter whose theology you're looking at.
Hey, whose side are you on?
Mine, as usual.
Like that. All the energy is stored down here, and all the fine minerals and precious stones in the earth.
Right.
Acts as a conductor, is that the word? Conductor or conductor?
Oh.
No, it's not the word.
I prematurely paused because I thought he was going to go where I think he's going to go.
There aren't many rocks that conduct electricity.
There aren't many precious gems that act as waveguides, let alone magnetic ones.
Yeah, but I'm thinking he's going to get into he'll say the word crystal. Maybe. Maybe. I'm only hypothesizing.
Capacitor? Conductor? I don't know.
He doesn't know the difference.
Yeah, you don't know, pal. That's the problem.
He doesn't know the difference between a conductor and a capacitor.
Maybe if he'd ever spoken to anybody who was even vaguely knowledgeable on this, he wouldn't have said Persephone.
Who?
Persephone. I'm just bitching about the fact that he's mangling every word.
Oh, okay. Yeah.
This is how it is. This is center-north vortex. That's it. All in there.
Yeah,
It
yeah,
goes
I've
like
got
this.
that bit. Yeah, I've got that bit now. I understand that bit.
There's your elliptics. That angle. There's your elliptics you see in the night sky.
Okay.
What you think. And this is what the moon's doing. It goes in and around up to the centre, comes back out and spirals it
Just think
back
it's
out.
hilarious that
That's what the moon's doing.
the caption said
In its
lipsticks.
cycle.
That's why I've got him on, because I think even the Google Translate's is confused.
That's what it does over the month. That shape. That's Tropic of Capricorn
So it
out
comes
there.
around, then does a loop.
This is Cancer. It steps in. That's new moon in here. You do not see it. It steps into here. And this is the one.
Okay, you get a different colour
The one
texture.
Fibonacci, where it spirals out.
Oh,
Then it goes
okay.
around and comes back in again. Goes around and then comes back in again.
So
Every month. New.
he's correlating the Fibonacci sequence to the orbitals of the moon. Okay.
New moon into here where you do not see it. Nothing seen in here. We see the moon out here and it's reflected over here. So it comes out. This is when you see it, when it's out. And the phasing of the moon is related to the energy in here. The sun reflects off the skin, but it's this energy in here that's creating the skin as the moon moves further away.
Does he mean the side of the moon that it's the sun shining on? He's saying the skin.
It sounds like it, yeah. Because he's pulled in this Nemean lion mythology into
Well,
it.
I'd like to show him some moon
He
phases.
says that it's the skin that is that is what we see. That's the lit up part.
Yeah, but that doesn't explain some of the phases that we get down here. Not for where it reflects, because how can it reflect from underneath? Otherwise, we'd see it over here. Oh, anyway.
Away from the centre. It spirals. You'll see it online. There's pictures of the way, like it. Time-lapse video of the...
Oh, is he talking about
That
oh shit! I wish I could remember the word for it. It's a sequenced photos they show of the, whether it be the sun. I've seen of the sun, how it tracks in the sky over a period of time, and it makes that
The
figure
solar
eight.
analemma.
That's the word. That's the word.
moon doing its thing.
you notice that was a very complicated explanation, Terry, because there was a lot of hand waving there. So that
Yep.
was a detailed explanation.
There was an
Okay.
upward spiral with the hand too. It was quite impressive.
Oh, okay.
Mm.
So we've got that can only work over the flat Earth, the whole concept. When you know what happens to the moon exactly. This is the male chamber.
It
The
may
male
work
chamber
over a
is in
flat
here.
Earth, but it's not what we
This
see
is
in
where-
reality.
It's related to the female down here on Earth. The bed, male chamber, where she could get pregnant. She comes out. The uterus is forming.
What the?
If she doesn't get pregnant, what happens? It starts coming away.
Wait a minute.
Oh my God!
And she doesn't get pregnant. But what happens when she does get pregnant? When's the birth?
Again. She'll have a period here if she doesn't get pregnant. She's pregnant, it'll keep forming. We don't see that in
Yeah.
our cycles.
So the moon,
But
so
the
the
old-
moon has a period now.
Yes.
Yeah, that's well, that
that's
explains the
weird.
blood moon, right?
Yeah, that's true. But then when does it give birth?
Ultimate time is in September on Earth when the moon comes right in north. And if we get a solar eclipse then, that's a very special time, and that's what the Sphinx represents. That's why it's looking.
He's not explaining the solar eclipse, though, is he? Because he just said it was there. Was
So if it gives, yeah, and if it gives birth, what does it actually give birth to?
two, yes. That'd be interesting.
In that direction at that date. They're looking for what happened on the 21st of August 2017, that exact same thing. That's what happened. We've got this.
Those crazy
Right.
eyes.
Brainery says, "Well, I know, haven't you word for?" Okay, male change.
This is coming from the centre here. Centripetal divergence.
Cent-
Convergence.
What centripetal divergence?
It's going back up the other side. This is the divergence. Divergence. This must be the divergence as well, coming back in there. So this is like a rodent coil, isn't it? Rodent coil, mathematics and geometry. But it's when it comes back around, a convergence. If I can, convergence when you start getting it coming back in.
And he's in trouble. He's in trouble now, Terry.
Yes, he was thinking.
He's in trouble now. You know why he's in trouble? Because he said both directions were divergence before, and now he's got to contradict himself.
Oh, it's the converging divergence.
Mm.
How do you draw a converging divergence? It's a bit tricky.
That's when you start getting that flower look. But anyway, where this happens, that touching point there where they cross, we get light in the magnetic fields. I'll tell you about a video. I'll give it to you now. This video. This is not a flat earther, but he describes the entire flat earth in this video.
A flat earther doesn't.
Related to
It's not a
magnetism.
flat earther.
It's called The Plane of Inertia and Source of All Life. All about magnetism. Look it up on YouTube. The Plane of Inertia and Source of All Life. Because that's
well,
where
I
life
don't
is,
think I will
on
be.
this plane of inertia. In the
Use peanuts out there. You can Google that if you want.
I always go to YouTube for my information, Terry. You know,
Oh,
like
yes.
it's my most reliable source of information.
Well,
is
how are we
YouTube.
supposed to learn anything if we don't look up this crap? I mean, information.
You're supposed to
field.
learn by just accepting what they say.
Okay.
In a big torus field. That's how it works. You just look into magnetism. NASA knows all about the magnetic fields. Looked it up, pair it up. Except they say the sun is 93 million miles away. It's absolute bullshit. It's right there in the picture for the recycling. It's how
But they're right about everything that agrees with me.
Yeah.
They speak absolute
works.
bullshit, except when it's something I agree with.
Yeah.
magnetic fields. I keep putting it there, but it's not. It's there. That's where it happens. Up like that. It's to do with this field coming down here. It's the counter forces. The Egyptians tell us about the counter forces of the magnetic field. It's the wind. It creates the winds, and then we get this. The star right.
The winds that creates the wind.
Yeah, magnetic
Hence,
forces
magnetic
create
forces
winds.
create the wind.
Yeah.
Yeah.
Yeah. Okay. But what if the wind's blowing in the wrong direction of which way his magnetic field say?
Rotations up there. We know they've got a big rotation there coming out of there,
Mm-hmm.
flowing up. Or maybe this there. Must be there.
Maybe this. He's got himself a cool picture, and he's got to use it somehow.
Yeah. It's like that
It's
piece
looking
of
more and more
jigsaw-
like a boob all the time.
It's like that jigsaw piece you've got on the table, and you've almost finished the puzzle, and you're going, "Where's it fit?"
I'm calling that he's going to use the eraser soon because he's got too much scribble there, and he's got to erase some to put more scribble there.
Yeah, I think he might be due for that.
Basically like that. This is represented in the Egyptian stories. The chariot wheels, the owl's eyes. Yeah.
Let me just pause for a second.
Yeah.
Oh,
Do
you know what I
like
was.
how he
You know what I'm
Do
looking
you like
at-
how he can? Go, Terry.
If he keeps drawing that like that, it's going to look like a uterus for a woman.
I like how he confirms his theories by saying "yep" to himself.
Yes.
Yep.
Yep. I'm right.
Yep, you're right, mate.
Yep.
Yep. My pause was about the rodent coil mathematics he was talking about,
Oh, okay.
which is
Yes.
complete bunk.
Yeah.
But essentially, this guy's come up with this whole new form of mathematics that apparently proves, even though he can't build it for himself, that you can make an interestingly wound coil that will produce perpetual motion.
Oh, right.
Ooh. Okay. I'll sign me up for
Which
that.
is,
I'll
and
give
this. Well, this is why he's drawn the lines the way that he has, because it's kind of a bisection of a rodent coil, which is helically wound around a torus, but it's bidirectional, so it's wound both ways. It's just complete bunk. Anybody who knows anything about magnetic fields will look at this and go, "This is useless."
Well, if he can come
And
up
it's
with
certainly not an over Unity or even a Unity device.
Well, if he can build an over Unity perpetual motion machine, sign me up. I'll give you all my money.
No, his excuse for that is he's not an electrical engineer, so he can't do the work precisely enough to actually achieve its potential.
There's always an excuse, isn't there?
Yeah. Well, once he gets his capacitor and his
And his
conductors sorted out, yeah.
This is magnetism, a ring magnet. We have our sun here.
Okay,
When they
where are we going
cross,
to
you
fit
have this
that?
light.
Where would you like to guess where he's going to put that onto the drawing on the board? I don't know which way has he got the picture going.
This light. If you watch that video, it showed you.
No, he's not going to use
before.
that one.
There's the torus. Look right round. This curved, reflective, concave, reflecting stuff back in where you'll get we're getting a hologram. Reflecting
Where
things
does he
back
get
in.
these images from?
Hologram. Just come out of here. Well, sits in here now. Anywhere between here and there.
Yeah, rub it all out. We can't see what you're
Oh.
doing.
Here it comes.
Yeah,
Sun and moon in here.
I told
All
you.
the planets. All
Get,
the,
get
all
confused. He
Well,
keeps
cool.
drawing
Yeah.
over his drawing.
This is the Tropic of Cancer. They just move between there, and then they're reflected on the side. Concave mirror.
The one thing he probably won't explain it, but I'd like to hear his explanation, is why it's called the Tropic of Cancer, Capricorn and Equator, in relation to the Earth's tilt for the seasons. But on the flat Earth map, he just says the Tropic of Cancer and the Tropic of Capricorn and the Equator. He doesn't. Yeah. Interesting.
He doesn't explain
Obsidian, I'm
anything.
saying that is. Plasma field where the sun is. But like I say, the sun, what the Egyptians tell us, is the sun is in many places, but only seen in one, because it's all about our perspective and horizon. We all see it because it's reflected out from here onto this concave mirror. So wherever we're standing, it'll be there in our horizon. It's a bit tricky to explain that one, but anyway. You'll see that in that magnetic YouTube video. What have we got here? Phoenix rising out of the ashes. And this is the phoenix rising out of the ashes. His wings, and it speaks of the talons, big claws, flying that way out of the ashes because the sun is moving this way. Out of the ashes of the magnetic field. This magnetic field. It's either the magnetic field driving the sun or the counter forces of the wind carrying the spheres.
Just pause for a moment there.
I'll be just saying it's the magnetic field. It's got to be the magnetic field because it's feeding the sun. It all goes to the sun.
Terry's gone AWOL,
Sun.
has he?
Magnetic fields are coming up, boom. And you
It took my brain a bit of a time to process that he was talking about the ashes of a magnetic field. What the hell? How can you burn a magnetic field?
Oh god.
That... Oh my god.
I would just like to take this paused moment to point out that this is so stupid that I'm actually drinking for the first time in 6 months.
Yeah. I don't think he's actually explained anything. It's
Nothing he said has had explanatory power.
No,
None of it.
It's just a random conglomeration of drawings and hand wavings and wrongness.
Well,
Go.
you're saying you're drinking again. Well, at least you didn't say you started drinking.
Yeah, don't burn your
Drinking-
magnets, Terry. Don't burn your magnets, Terry, because out of those ashes will arise something like this.
The Phoenix.
Yeah.
And I've seen that movie. It didn't end well for the aliens.
Yeah.
Can you buy how much is magnetic ash on eBay these days? Might be good for your garden.
Yeah.
remains floating off to the rest of the toroidal field. The electrons. Boom.
Boom.
Because they're moving quite fast apparently.
Boom.
Boom. Electrons. Boom.
Electron. Boom.
There you go. We've got a new quote. Hashtag electron boom.
According to science. Star trails. We've done the star trails.
You've done the star trails?
Star trails. Reflected. So you're probably you'll get them all over the place. Wherever you are. Because it's just the way how it works, a concave mirror, a circular concave mirror.
Pause.
Yes.
We get I'm going to beat you, Terry. What do you
No.
we get star trails all over the place.
Yes. You beat
No,
me, you
we
bugger.
don't.
I was going to say that.
We don't get them all over the place. They go in circles.
Oh my.
Oh dear.
So I'd like to see somebody like this actually try and model it out mathematically, or even get a freaking ray tracer or something, set up your scene and try and duplicate what we see. You can't do it.
I want to see a scale model.
Scale model.
I'd be happy with CGI.
Yeah. Oh dear.
Put it in Blender.
We'll get our mate Dean to do it. He's good with all that.
Wherever you are, you'll get the picture. It
He's been wanting to try to do a flat Earth model. This might help him.
centralises the light into your horizon, your perspective.
What? I know it says sexualizes, but is that what he said? That's what it said in the Google Translate said. What?
I think
And the
he said
secular
conceptual-
concave.
I think he said conceptualize.
Oh, okay. I think Google Translate's just having fun with him.
Mirror, a circular concave mirror. So wherever you are, you'll get the picture. It centralises the light into your horizon, your perspective.
Centralizes.
Yeah.
Yeah,
No matter
centralized.
where
Yeah,
you
but
are,
sexualizes is more funnier.
Yeah, it is.
I like the secular concave mirror.
Oh, okay.
you're looking, you'll see one. You're seeing yours, he's seeing his. That's the way it works. We just need someone to do the experiment. Make up the concave, get yourself a flippin' clear glass shape, that shape with the same arch there and there. Spin the water, put some luminescence in there and watch it. What happens up in the reflected concave mirror?
Okay.
But put some luminescence in there.
Does that, come by the kilo? Do we get little bottles of it?
Well, I think it's on sale at the
Can I-
moment.
Can I buy some to put in my washing next time?
Yeah.
Oh dear.
Dip compass. With the dip compass that points down
Oh, I
on the
see a
south,
duck.
it points down on
I
the
seen a
north.
duck. I seen a
Dip
duck.
compass.
There, see the duck. Duck. The duck compass.
Sounded like you said dick there.
No, but I told you I see a duck.
Compass.
A duck.
With a dip compass that points down on the south and it points down on the north. And it points up at the equator. Points down there,
Hashtag duck compass.
points down there, points up there.
Compass.
Because it's pointing to the source.
Look up a duck.
The source is coming up here. The source of the energy is coming up here. The energy is up there. Negative, positive. North, south. This is basically north, south. They are the same. In a magnet, there's no north and south. It's just centripetal divergence.
What? Centripetal divergence. But
Or secret people divergence in this case.
oh, okay, secret people.
Secret people divergence.
Okay, secret people. It's in code, see. It's in code. We can't let the truth out. We have to do it in code.
Yeah.
But if there was a north and a south,
Yeah. Which there is.
if we cut that in half, that would be north and that would be south, right? But no. When you cut it in half,
No?
you'll have a north and a south here. Cut it again, you'll have a north and a south.
What? You have a not? How do you
Yeah,
get...
it's one of the
cannot-
principles of it's one of the principles of magnetism, Terry. That if
Ah.
you break a magnet in half, you don't get a
You
north
get
half and a
monopoles.
south half. You get two magnets, both with the north and the south.
Yeah, I know that.
Oh, is that what he's saying? It sounded like he was saying if
Yeah.
you cut them in half, you get two magnetic monopoles.
No, I think he's saying that if you halve it, you get a north and a south here and here as well. That's what I thought he said.
Okay.
I'll take your word for it.
Cut it again, north and a south. Centripetal divergence and convergence.
And now for another non sequitur.
Hmm?
Elliptical angle in the vortex. So there's your elliptics on these angles, because that's the way it goes, isn't it?
The elliptical angle.
That's out there.
Yeah, elliptical
There's
angle.
your
Yeah.
elliptics.
What
Reflect on the night sky.
is an elliptical angle?
Oh, look, ducks reflect.
Look, ducks.
More ducks.
There's no tilting axis.
That-
So look, go. This winds up, winds down. So it depends on where.
this winds up, this winds down. I think you're winding us up.
The celestial body is.
He keeps saying
on this-
elliptical.
Yeah, well,
He keeps saying elliptical, but it only looks like an ellipse from a certain projection. It's actually circular.
yeah.
Plane.
And I want to know what an elliptical angle is.
Yes, that
Yeah,
one
true.
had me beat that one.
Elliptic plane. Understanding what all religion is all about.
When he says elliptic plane, he keeps saying elliptic plane. Do you think he might possibly mean ecliptic?
Ooh,
Maybe.
okay.
That would change some of the things he said. It's all still bullshit, but
Yeah, but
I don't know.
might make more
Instead
sense.
of 100% of it not making sense, only 99.9 wouldn't make sense.
I might take another 9 on that, but yeah, basically.
Yeah, I'd take a few more nines.
In Egyptian myths,
Oh, okay.
e.g. the king's chamber in the Great Pyramid, in its association to centre Earth, the Ben stone, first kingdom, second kingdom.
Third kingdom.
It's not
You
what
want
you're
the
told.
third?
If you're a tourist going to Egypt, they don't tell you that. They don't even know. Only a few people understand the true story left behind. The Egyptians are giving us the blueprint to exist our life. It's our monopoly game. You win the big prize. You'll understand all that. Moon cycle, the apple shape.
Understand what he understands it?
I don't. I understand the words. I just don't understand what he means by them.
Yeah.
And going into the male chamber.
Oh,
We've done that. Male chamber. There's the moon cycle.
yeah, with the moon,
sounds a
with
bit
its
gay,
to be
periods, its moon with its periods, with its pregnant phase and male chamber. Okay.
On a ball. That's flat Earth. You know, when Newton talked about an apple falling off the tree, no, he knew what the apple really meant. There's no flipping gravity. Well, gravity, there is gravity, but it's not really gravity, it's magnetism.
That was a jump,
Yeah,
wasn't it? That was a jump from the moon thing to the. Then
Did he just contradict himself about twice in the same sentence?
yeah, that's. He was talking about the cycle of the moon.
Can't work on a ball, that's flat Earth. You know, when Newton talked about an apple falling off the tree, no, he knew what the apple really meant. There's no flipping gravity. Well, gravity, there is gravity, but it's not really gravity, it's magnetism. It's all magnetism.
There's no
Magnetic fields. The human body's made up of atoms. This is basically an atom. We all have negative, positive. Attraction, repulsion and attraction. Attracted to the earth. Now the force that's repulsion holding us together maybe, I don't know.
Repulsion holding us together. Sorry. I'm really choked on my breath.
I was drinking big coffee then.
How can you get repulsion holding us together?
Yeah. Oh,
Oh dear.
I hope your monitors are far enough back for this one.
Oh my god.
Oh, right. Okay, here we go. Catch our breath.
Yeah.
Beast, the serpent, the dust, the beast in the religion represents beast, magnetic fields. Along the ground thou shalt go. There's dust, see? And there's fine particles of dust the magnetic field travels through.
I
This
have
is what
another
this-
major complaint with that.
Okay, what do you got?
He's just associated a word he's just claimed that an ancient word that predates the word magnet actually meant magnet. I want to slap this guy.
I must have missed that bit.
The beast, magnet.
Religion represents beast.
That's what he says.
Yeah. Oh, okay.
So essentially he's saying, here's this ancient word that kind of sounds a little bit like a modern-ish word.
Right.
So therefore that's what it meant. That's what they meant before that word even existed.
Oh.
They were saying magnet.
Oh, okay.
Because they knew that at some point 1,000 years in the future, somebody would come up with the word magnet.
Well, that wouldn't be the only word they've
It angers me.
Magnetic fields. Along the ground thou shalt go. There's dust, see? And there's fine particles of dust the magnetic field travels through. This is what it is. They call it dust. The magnetic field travels through it. This is like a capacitor and the dielectric. Hard for me to explain, not being a scientist, but
I think that's about the only honest thing that he's actually said. That actual little statement there.
That single statement, yep.
Yeah. That's it. That wraps up
I'm
the
not
whole...
a scientist, but I'll tell the scientists that they're wrong.
Yeah.
that's the snake. What the snake represents, the beast. The beast is the snake, and that's the magnetic field. That's the flow of the magnetic field. The beast. Along the ground thou shalt go, and above the fields, etc., up to the sun. Because there's a serpent that said, "You will not die. Your eyes will be opened." Because this is all related to the man's sun down here on earth, his pineal gland. That's the sun of man. Physical sun, spiritual sun. Two realms, physical, spiritual. Everything is all related. You can't debunk this. It's all related with nature. Your spiritual being is a human.
He's put up a challenge. You can't debunk it.
Human being, your physical
To be
being.
fair,
Yeah.
to be completely fair, you can't debunk absolute nonsense because there's nothing there to get your teeth into.
Okay. But it's interesting to...
Animals,
I can deny it.
everything.
Yeah.
Torus hyperboloid. So the big torus field, the hyperboloid, done that. Rodent coil, there's a rodent coil. Two spheres of the human brain, fractals of Earth. Two spheres of the human brain. Your pineal glands in here, the two spheres. Because we're fractals of Earth, we're all associated with Earth. All religion tells us that.
Come on, you're nearly winding up now. What do you got left?
So the pelt. So Hercules, what's Hercules doing? He catches the lion in the den. And he can't kill it with his arrows or anything. Because there's nothing there to kill. He hasn't got, this moon hasn't got the skin on it. There's nothing there to kill. You can't kill it with an arrow or whatever, he spears. That's what he's telling us. But then he said he skinned it, because you have it's de-skinned. I've always told everyone, this is only forming skin. The moon is only forming a skin. An electrons form a skin when they cool. Something to do with cold, just like out here. The electrons have to come through the ice to line up to get themselves back up to the sun. Through the sun. Through the ice.
Oh no!
Electrons have to come up through the ice.
Skin
Yeah, they form a
when
skin.
they cool.
When they cool, yeah. Yeah, I caught that.
Ice.
The stupid, it burns.
Electron forming the skin. So in the story, he ends up strangling it because he couldn't kill it with a weapon. Strangled it. This is strangling it.
Oh, is
Yeah.
it? Okay.
Look like he's strangling it.
Yeah.
Frickin' does to me. Strangled it to death. Then he's
Frickin' does to me.
Oh, it ended abruptly.
Maybe he went off to choke something else.
Yeah.
after that
dear.
performance. Oh my!
Mippet's going.
Where to even-
What's he on about? I truly have no idea. Well, you want to be the only one?
I can't even.
I think I'm enjoying this guy. Not in the good way, but oh
That
dear.
was fun.
Did you like
That
that,
was
John?
definitely something.
Did you like that, John?
Oh, thanks, mate. Yeah, good on you, mate.
Hope you didn't start drinking, because Monk said he had to take it up again.
Oh, I gave up after that.
Oh, you've given up.
I
but wait, there's more.
I can't even.
You can't even. You can.
I think that's what happens when you drink too much over a long period of time.
Uh,
That's what it does to your brain.
This will be a relief.
Do you need this? Does it reach the subtitle bit? Because I think you need that bit here.
You can full screen it.
I can't.
Scroll down. The double arrows will full screen it if it's
Yeah,
not going to
no,
take
but
up
it won't
in your display
take up.
space.
It won't take up my full screen.
Oh, just zoom out a little then.
I'll zoom in. Yeah, I can zoom in a bit.
There we go.
You haven't seen my screen. What I do everything on the single monitor.
Okay.
That works. I have no problems yet. Touch wood.
Точно тут это было. Стою я вчера, в общем. Сигарету курю, никому не мешаю, и вдруг, откуда ни возьмись, такая бешеная машина. Ну, примерно вот так вот, ну, та желтая была. Ну, что, завтра на этом же месте? Точно тут это было. Стою я вчера, в общем.
I don't.
Just like that, but it was yellow.
И вдруг, откуда ни возьмись, такая бешеная машина. Ну, примерно вот так вот, ну, та желтая была. Что, завтра на этом же месте?
So, same place tomorrow? It might be a blue one tomorrow. Or it could be a white one. You never know your luck.
Oh dear.
Oh no.
I
So
like
Terry, I
that.
found a mathematical shape that's similar to what he thinks the moon's movement is.
Mhm,
Popped a link in the
mhm.
side chat
Yeah,
here.
yeah, I'm on my way. Oh, it's got numbers. I don't know what they mean.
Don't worry about the numbers. Just look at the pretty pictures.
Okay, I'll look at the pretty pictures. There you go. There's the pretty pictures. So it's a limacon or limason,
Son.
is it? Okay. It's also called a also called the imaxon of Pascal. It was first investigated
That's a little
by
L.
Duro, who gave a method for drawing it in a whatever that is in 1525. Rediscovered by Edson Pascal, father of Blaise Pascal, and named by that person in 1650. The word imaxon, if you want to pronounce it that way, comes from the Latin.
It's an L.
As an L, okay. Comes from the Latin limax, meaning snail. Okay.
Yeah, I knew I'd seen the curve before. That's
Yeah.
essentially like that one on the right there is pretty much exactly what he
That
was
one,
showing. Yeah. But I'm damned if I can figure out how he gets that from something traveling around in the apparent vortex in the middle of his bizarre model.
Yeah, to make the moon go round and then come back around and loop back on itself.
Yeah.
That was interesting.
I got no freaking idea how that works in his.
Oh, look at all those! Look at all those numbers and letters. Well, we've got a math guy here. He'd know all about that. Where's Tony when you want him?
The 1 plus cos phi in the middle of those 5 is called a cardioid. And I knew I'd seen the modified version of that.
Well, isn't that a
You
circle?
can get some nice shapes in polar coordinates like that.
Yeah,
that's a circle.
Yes, well done.
Interesting. Yeah, learn. Night, Mippet. Thanks for the headache. Okay, you're welcome.
I can relate, Mip.
Okay. I don't know how long we're going to be going tonight, depending on what we get done and what we've got. You got anything, Paul, for entertainment?
Yeah, I have.
Or
just
entertainment or knowledge?
Knowledge tonight.
Okay.
Maybe I'll do some entertainment next week because we're about due for some entertainment, aren't we?
Mm.
But knowledge tonight.
Okie dokie.
Let's see. There you go. Have you got that up?
Yep.
Cool. So we'll do from 500 to 1,000, and then we'll do from 1,000 to 1,500 AD.
Mm-hmm.
See what sort of things were discovered in those times. So you can see I've got lots of pictures up there.
The one thing I might like to point out, Paul, is don't go too much into the Industrial Revolution era, because that's where I was up to in the Ancient Technology series.
That's fine. Yeah. Yep. No worries. Okay. So the first thing we've got here, let me click on it. We've got John Philoponus describes he describes the notion of inertia and states that the motion of a falling object does not depend on its weight. And so he was basically going against Aristotle at this point. So this is a sort of like preemptive of what Newton was saying. He preempted Newton's laws of motion. But people didn't take any notice of him because Aristotle was held in very high esteem, and anyone that said anything against Aristotle had been crazy. So they didn't really take much notice of him, but he had it right. Yeah. And then by 600 AD, Varahamihira is the first to describe comets as astronomical phenomena that are periodic in nature. So this person observed the comets and realized that they were astronomical objects, they were real objects that had a periodic nature to them. In other words, that they came back around, that if you saw them once, that you would see them sometime again in the future. So they were taking notice of the sky. Now, this guy, Brahmagupta, he features a lot in the early history of mathematics, especially in India, because he was Indian. So he actually discovered quite a lot of things. And one of the things he did was he extends the rules for arithmetic to include rules involving zero, and also extends the rules for negative numbers. And the sort of language he used, you can see up the top here, these are his rules that he actually proposed, and they're all familiar to us, but the language that they used then was a little bit different. He says a debt minus zero is a debt. So here, when they say debt, they mean a negative number. A fortune minus zero is a fortune. So what do you think a fortune is, Terry?
A fortune minus zero
is a fortune. Yeah. So a
If a
fortune,
debt is a negative, then a fortune is
a fortune
Positive.
is
Positive.
a positive number.
There we
Yeah,
go.
a positive number. Yeah. So 0 minus 0 is 0. We all know that. A debt subtracted from 0 is a fortune. So what he's saying there is if you subtract a negative number from 0, you actually get a positive number. A fortune subtracted from 0 is a debt. So if you take away a positive number from 0, you get a negative number. The product of 0 multiplied by a debt or a fortune is 0. So essentially you're saying that anything multiplied by 0 is still 0. The product of 0 multiplied by 0 is 0.
I just have to double check with Riley for that one.
Oh, okay. Yeah. This one's interesting. The product of 0 multiplied by a debt or fortune is 0. Yeah, but the next one. The product of 0 multiplied by 0 is 0. So if you have nothing and you multiply it by nothing, you've still got nothing.
Hey, I got nothing.
Yeah. The product or quotient of 2 fortunes is 1 fortune. So you're saying if you multiply 2 positive numbers together, you get a positive number.
Yeah.
And then he realizes that the product or quotient of 2 debts is 1 fortune. So in other words, if you multiply 2 negative numbers or divide 2 negative numbers, you also get a positive number.
Positive number. Yeah.
And the product or quotient of a debt and a fortune is a debt. So if one of the numbers is negative and one of the numbers is positive, you'll end up with a negative number. And that's essentially what the next one says too.
Yeah, okay.
So they figured that out a long time ago.
Yeah, I remember hearing about the north part of it being invented by Indian thing.
Yeah.
A lot of our modern mathematics started out from fundamental principles that originated in India.
Yeah, India, Pakistan, and China.
Yep.
Brahmagupta finds an explicit solution for the quadratic equations. You know that complicated formula that you use, minus b plus minus the square root of b squared minus 4ac all over 2a? Everyone remembers that, don't they?
Absolutely.
No. Well, he was the guy that discovered that. So they knew that way back then. Yeah. Brahmagupta produces an infinite number of solutions to Pell's equation. Pell's equation is the one up in the top right-hand corner here. I don't know whether it's too small for you to see or not. But here, an example of a Pell's equation is x squared minus 2y squared equals 1. If you solve that so that you get whole integer numbers for the x and the y, there's an infinite number of those solutions. And he came up with an infinite number of solutions, but not all the solutions. So he defined a set of them, but not the entire set. Same guy extends Heron's formula to generalize cyclic quadrilaterals. Do you know what a cyclic quadrilateral is? Give you a clue. It's in the diagram right above there. A cyclic quadrilateral is a four-sided shape that you can draw inside a circle. So all four corners must be touching the edges of the circle. And then that's a cyclic quadrilateral. And he made a formula that you could calculate the area of that quadrilateral just by knowing what the side lengths were. Same guy discovers the second order interpolation. So instead of just guessing linearly what's in between 2 points, he used second order equations to interpolate between 2 points. So they're getting quite complicated now.
The second order interpolation is nonlinear, yeah? Yeah,
that's right. Yeah. Brahmagupta invents a symbolic mathematical notation that is used in India, the Near East, and eventually in Europe. So it's basically the beginning of our modern use of mathematical symbols to represent things like pronumerals and operators and functions and stuff like that. Same guy introduces the first approximation of a transcendental function in the form of the sine approximation formula. So here, they're now starting to calculate things like sines and cosines using actual formulas. Next one. So here, where am I? Let's go here. Vicenna describes the integer logarithm. So the logarithm being a non-linear scale, like the logarithm of 100 is 2, the logarithm of 1,000 is 3, the logarithm of 10,000 is 4. He was the guy that developed that. He didn't yet understand or use decimal logarithms yet, but at least he had the notion of integer logarithms. Mahavira determines the expression for the binomial coefficient in terms of factorials. So they understood what factorials were. Do you know what a factorial is? Anyone?
No.
It's the result of multiplying all of the integers from 1 to n.
Yeah. So 2 factorial is 1 times 2, Terry. 3 factorial is 1 times 2 times 3. 4 factorial is 1 times 2 times 3 times 4, etc. And so they used this to get the coefficients of the binomial expansion. So getting pretty complicated now. Same guy writes down a factorization for the difference of cubes. I think I've got that factorization there somewhere down the bottom. It's probably been cut off on the display, but it's down there. Al-Kindi writes about deciphering cryptogenic messages and thus introduces the first use of statistical inference. So basically, if you do a simple substitution code, like swapping the letters of the alphabet round and then writing out your sentence.
The classic Caesar cipher.
Yeah, that's right. He used a statistical method to break those. So he looked at the occurrence of certain letters in certain pieces of writing, and he could use the statistics that he gathered from that to predict what the letters were in the code. So he then inferred what the letters were really representing, and so he could break the code. Algorithms for numbers were written in place value systems are developed. So, you know, those things where we, when we do an addition, how we line the numbers up under each other if they're place value, and we carry little ones across and stuff like that. All of those sort of things were developed around about that time. The little methods that we use for doing basic arithmetic were all developed. How do you say this? Haliuda organizes the binomial coefficients into a triangle, and we know of that as Pascal's triangle. That's that triangle down below there. It's probably a little bit too small for you guys to see. But it's where the top of the triangle's got a 1. The next row down is 1 and 1 on either side of that 1. And the row underneath says 1, 2, 1. And any number in the triangle is obtained by looking at the 2 numbers above it on either side. The sum of those 2 numbers gives the number underneath, and they actually end up giving you the coefficients of the binomial expansion. Then Ibn Sa'd discovers Snell's law. So right back in the 10th century AD, they did understand Snell's law. They knew what Snell's law was. Obviously, they didn't call it Snell's law because
Maybe we should call it Ibn Sa'd's law.
Yeah, because he didn't come till a lot later. But they knew about it. Yeah. And then Manjula in India discovers the derivative, deducing that the derivative of the sine function is the cosine function. So even though they didn't know calculus as such, they did have the concept of what a derivative was, and that they knew that the derivative of the sine function was the cosine function. Bhattopala lists the names and estimates the periods of certain comets. So they were observing a lot in the sky, and they actually gave some of the comets names and estimated the periods that they would, like when they would see them again next. Where am I? Go to the next one. Yeah. Al-Zahiri al-Zaragali in Islamic Spain discovers the apsidal precession of the sun. So they're taking pretty accurate astronomical measurements by now to notice that the actual sun, the way the sun wobbles, it wobbles a little bit different each time. Because as the planets go around the sun wobbles. The sun doesn't stay in the one spot. It actually wobbles a little bit. And he noticed that and measured the actual wobble of the sun. Alhazen discovers the formula for the sums of consecutive quartic powers. And the same guy systematically studies optics and refraction. He investigated the properties of rainbows, eclipses, and moonlight and luminance.
Did he find out that it cools things?
No.
I bet he didn't.
I bet he didn't. Yeah, that's right. He wouldn't have thought of something so silly. Shen Kuo discovers atmospheric refraction and provides correct explanation for rainbows. So way back then, they understood why rainbows occurred and the actual mechanism for rainbows occurring, that it was caused by refraction through raindrops.
1,000 years ago.
Yep, that's right. Yep. Shen Kuo discovers the concepts of true north and magnetic declination. So they understood that there was a geographic north and a magnetic north, and that the compass didn't always point to true north. Same guy develops the field of geomorphology and natural climate change. So climate change has been around for a long time. Yep. Robert Grosseteste writes about lenses and optics and asserts that models should be developed from observations and then predictions of those models be verified through observation. And so it's basically the first steps. It's the preempt of the scientific method, the modern scientific method. Yeah. Roger Bacon publishes translated Greek and Arabic works on mathematics, optics, and alchemy, and details his methods for evaluating these theories. So he basically translated a whole heap of the ancients' works and then went about evaluating them, how good they were, and gave his reasons for why they were good or not good. Yeah. He asserts that theories supplied by reason should be verified by sensory data, aided by instruments, and corroborated by trustworthy witnesses. Again, it's a precursor to the scientific method. He's saying you can't just think about things like the Greek did and then proclaim something to be true. You've got to actually test it, and it's got to be repeatable. Or someone who's reliable should witness you doing it.
And 800 years later, we're still trying to teach flatties about that.
Yeah, that's right. Yeah. Okay, then we come. Eyeglasses are invented in northern Italy. This demonstrates knowledge of human biology and optics. So obviously, to make glasses that work, they had to understand optics, and they also had to understand how the human eye worked for them to be able to correct that disability. The Scottish priest Duns Scotus writes about the mutual benefits of trade. So this is in the field of economics. So he basically explained why it was good that countries should trade with each other. Tusi develops a numerical algorithm for solving cubic equations. Baruch ben Malka, sounds Jewish, formulates a qualitative form of Newton's second law for constant forces. So this is well before Newton proposed his laws of motion. Madhava develops the Taylor series and uses it to derive the Taylor series representation of the sine, cosine, and tangent functions and the Leibniz series for pi. So by now, this is at 700 years ago, they've already got highly complicated mathematical formulas to calculate the values of these transcendental numbers like E and pi.
And we've got everything we need to finally do full tree.
Yep, that's right. Discovers error terms in infinite series. So if you have an infinite series and you want to add up that infinite series, this guy found out that you could quantify the error terms in an infinite series. And he also discovers continued fractions. Do you know what a continued fraction is? They're
So
weird.
that one at the bottom?
That one at the bottom, if you can see it, yeah, that's a continued fraction, where it basically goes on forever down there. That's another way of writing certain kinds of series. You can write pi in terms of a continued fraction. Then we've got convergence tests for infinite series are developed. So if you've got an infinite series, they could test to see whether it converged onto a number or whether it diverged to infinity. Madhava solves transcendental equations by iteration. Same guy discovers the most precise estimation of pi with an error of only, I think it's about 3 times 10 to the negative 13. So he was able to determine pi to that degree of accuracy, which is way more accuracy than they would have ever needed to use in construction or anything like that. But it's sort of like the precursor to modern day methods of determining pi by using iteration, using algorithms to actually determine the value of pi. They use algorithms today with computers to get the value of pi out to trillions of decimal places. And last of all, we've got John Buridan provides a basic explanation for the price system. So this is in the field of economics. He explains why prices are like they are, you know, like laws of demand and stuff like that.
Right.
And Parameshvara discovers a formula for the circumradius of a quadrilateral. So if you draw, like we had before, a quadrilateral inside a circle, this other guy, Brahmagupta, could determine what the area of that quadrilateral was, but this guy could determine what the radius of the circle was that you drew around it, just by knowing what the quadrilateral was. An infinite series for pi is discovered. And last of all, this guy develops a model similar to the Tychonic system. His model has been described mathematically more efficient than the Tychonic system, but due to correctly considering the equation of the center and latitudinal motion of Mercury and Venus. So it was kind of like a precursor to the Copernican system. He got it pretty much right that the sun was at the center and everything went around the sun. And he was almost correct, but not quite. So that's where we're up to in 1500 AD. That's what I've got for you today.
A lot happened.
There you go.
Yeah.
A lot happened then, yeah. And so things start going more century by century after this because a lot really happens.
I'd like to have been a fly on the wall when they were first developing these mathematical concepts for how they were coming up with it and what they were doing.
Yeah.
Can we just pop back to that final slide for a moment?
Yeah.
I thought I let Blue in there a minute ago, but I don't know what happened.
Disappeared. I'll have to click all the way through the
sorry, man.
the thing and share it again. I'll get there eventually.
I hear Matt clicking.
Yeah. I'm almost there. Right. Okay, let me share that then. There you go.
I just wanted to point out and I know a lot of work over the centuries was done on this, but this discovery was not just a landmark discovery. It's also beautiful. If you look at the calculation, the infinite series calculation for pi, it's an alternating addition and subtraction, or subtraction and addition, probably, of the inverse of the negative numbers. And the fact that that is what pi is, or that's a way that you can generate pi, is fundamentally amazing. It is.
I find that. Yeah, I find that absolutely astounding. Yeah.
And
absolutely.
For somebody to spend his life working in mathematics and eventually arrive at something like this must have been an amazing discovery for him. If I were to discover something like this after having devoted my entire life to mathematics, it would have just made me cry.
Yeah, and that sequence there can be used to add more digits to the value of pi. Like, you can use that to actually calculate pi, and the more terms you use, the more accurate you get your value of pi. Unfortunately, you have to go out to about 100 terms or something like that to get a reasonably accurate value of pi. It converges very slowly onto the accurate value of pi, this particular series. But there are other series or other ways of calculating pi like this, where you can add 3 or 4 digits to the accuracy of pi every time you do an iteration. And so they use those a lot more in computers because they work a lot quicker.
Well, especially because doing like any of the 1 over prime values tends to be, once you get up past the 8th or 9th prime, they tend to be semi-transcendental themselves.
Yeah.
Some of them don't repeat for hundreds of digits, and that's from a division of, or the inverse of a value that's only 4 digits. And this is what makes it particularly difficult to get accurate values for pi on computers, because in order for you to get that accuracy, you need to be working. If you're working with this formula, you need to be working with numbers that are potentially many thousands of digits long at every step.
Yes.
And computers are really shit at that.
Yeah, that's right. Because you've got to store those numbers.
Yep.
Yeah.
And every operation that you do is now working on potentially megabytes of data on either side. And that's assuming that I'm trying for the first trillion digits of pi. Well, in that case, I need probably a couple of terabytes of information, of actual calculation of what 1 over 23 actually is, in order to get that kind of accuracy. Which is why the iteration, why the methods that we use for calculating pi these days are very different from that.
Yes.
But it's so pretty. I had to point it out, and I can only imagine the emotional impact that would have had on somebody who's devoted his life to it.
Yep.
I don't usually get this emotional about maths, but you guys got me drinking, so I blame Terry.
Oh, dear.
You had to blame somebody.
It's never my fault.
Oh, no.
Okay, it's usually my fault.
Maybe we can get Monk to do a session on the beauty of mathematics each stream.
Oh. Oh, we might have a new employee, you think?
That one is to be fair, that one is actually one of my favorite mathematical formulae of all times. Just the pure beauty of it is
well, we don't want to take Paul away from his job.
No.
No?
I enjoy going through Paul's presentations. So he's dug up some really, really interesting stuff.
I'll tell you what. I'll make a competition between the two of you. The first one to come up with a title for their segment, because Paul's already got his segment.
I have to point out, though, that the things that I've put in there by no means covers everything that was discovered in those periods.
No.
That would be impossible.
Yes, it would. Which I have found out doing ancient technologies is it's
Yeah,
hard.
yeah.
It's hard to pinpoint what you can pick out of those time periods, but because there's so many different things that happen.
Especially when especially when you've got such a large period like that covered 1,500 years of history where so much happened.
Yeah.
But those were some great points from that period.
Mm. So I wasn't covering math. I was only or science as such. I was only just trying to cover just the technology side of things, like the water wheels and all that sort of stuff. Anything from sewing machines to printing presses and glasses. When glasses first, the inception of people wearing eyeglasses and lenses, and it's so hard to find stuff, but it's out there, bits and pieces.
It's tough because there's so much that has been lost, and I'm not talking about ancient, high-tech civilizations or anything, but
no.
I mean things like the Antikythera device. We don't really know that much about it. We just know that it exists. We can make some guesses at what it might have been used for, but we've got one.
Well, we
don't really know what it's.
We made a replica of what we think it did, like predictions of Olympic Games and sun, the moon, and things like that. But that's what they think it could do.
Or very little historical reference even to such a device, and to find this thing was, I think, shocking to a large part of the community that studies it.
It might have been just a one-off device that was made.
It could have been.
Yeah.
Or there could have been thousands of them, and that's the only one that was preserved in such a way that it survived.
But it was made of a metallic substance, so you'd think it would have survived in other places.
I feel like, and I can't back this with any research or anything, but I feel like there was a lot of reuse of componentry. That, the sort of technology that went into creating those, the clockworks and mechanical devices would have lent itself very, very well to parts being reused in other devices. So when one breaks, you take what you can use and make something else. That seems it fits with me anyway.
Yeah, which did happen at one time. Well, that's what happened during the Dark Ages, with a lot of after the Romans, even in places that they just stripped the place of what they needed and completely abandoned it and went off and did their own thing and left all the technology
which is why
behind.
we find these ruins that all we find in them are the broken bits of the walls and the occasional trash heap.
Yeah.
We don't actually find fully functional devices because they all took them with.
I was only just looking at a
where
video
they could
the other day of I think it was in the Mayan or Aztec ruins, that there is rocks that they cut the stones, and there's stones that are actually used that predate some of the buildings that they had built, like some of the pyramids that they were building. They built them with more modern materials, and there's bits and pieces of rocks and stones that are in amongst it that predate the pyramid. So
yep,
just makes you wonder.
Well, we go on about recycling, but obviously it's been around for a long time.
And it's hard to date a lot of those places because the carbon dating only works for organic substances that they can actually use to date things, like the rock and all that stuff's a bit hard to date 100%.
Well, the best we can do with most rocks is, if you're talking about radiometrics, you're going to look at when the rock was formed. So there's a lot of stuff that we can't figure out from that. There's some stuff you can get from tool marks. But then, going back to the Aztecs, they've got some places that were so well fit together that for a long time we had no clue how they even approached it.
Mm-hmm. The other part of that astounds me is how did a pyramid and Aztec pyramids ended up being the same shapes? Completely two different cultures and time periods. What did the Egyptians or some culture went across there and copied, or I don't know. It's a mystery, that one. Have we got anything else to watch before we finish up tonight?
Just before you do, Terry, that would have been the image that Monk was talking about with the concave mirrors put together in such a way that it makes it look like an object is floating above the surface. It's not really a hologram. It's just an image that's being produced in space above the mirrors there. But people can think of it like a hologram, but it's not really. Yeah, that's what you were thinking of, isn't it?
That's exactly the device I was thinking of. Yeah.
Yeah, I have seen them things. Yeah.
Yeah.
Yeah, the actual object's actually in the bottom of it, and then when you look into
the bottom of it, that's right.
Yeah, you can see in this particular image you can see the true object underneath the reflection of it.
Yeah.
But yeah, it's just fascinating the way that that optics can produce those kind of illusions.
Yeah.
Which video we got? Terry says, Peter says a Pip story. Where's that? The Inappropriate Children's Guide to Deities, Demigods. Okay, I've got that to finish up on. Oh, premature, what do you call it?
Premature pipulation.
Good one, Mark.
What do we got? We haven't played Anton for a while, so what's he got there? That's 11 minutes. So we can either play one 11-minute or two short ones. Mr. Sensible. I'll put it in the peanuts. Anton, Mr. Sensible, or who else have we got? And Simon Dan. I'll give you those three choices. So just vote by just typing Simon, Mr. Sensible, or who's the third? Oh, Anton. Those are the three choices. We'll see if we get any choices out of that. Andrea wants Anton. Why can't I tag Terry? That's easy, Phil. Here. I'll help you. There you go. Now you can tag me. Anton. Oh, looks like we're getting an Anton. Okay. I don't mind. Peanuts. Can't argue with the peanuts, can we? Okay. We got. What if the planets were really that close to each other? Or we can go back to the one he did back. Where was that one he did back further? The largest craters on Mars and what created it. So you want the Mars or do you want the planets? Thank God it's flat, said Antonio. Yeah, we got Antonio flat. It's okay. So we can go back to the largest craters on Mars or the newer one with the planets. Yeah, the last one he did was what if planets were really close, something that close to each other, or the Mars craters? I vote for the Mars crater one. That seems interesting. Where'd that go? Planets? Yeah. Oh, you want the planets, Zebulon. Okay. Mars heads. Planets for Zebulon. So we're going to vote for one. Mars, planets, Mars. Oh, we've got two Marses. Zebulon, I think you're going to get outvoted here. Mars bar. So we've got three. Hey, John, you're in here. You can't vote.
Bugger.
You thought you'd pull the Swifty on me. I thought John Stockmars. But hey, wait a minute, you're in here. I think we might get a Mars. Zebulon wanted planets. John said Mars. John Rapp, that is. Very nice people after Mars. I've seen the Mars, Miro said. Oh, okay. Busted. So either one more Mars or... because I don't think Zebulon's going to get a second vote for his planets. So I think he might be missed out on the planet by the sound of it. So I'll start getting the Mars one ready. So you can hurry up, quick. No voting. If you don't vote quickly while I'm getting it ready, it'll end up being the Mars one, if that's what you voted for. Or suggest, sorry. Not really voting, is it? Okay, Phil, I'm trying to get a video ready. What? Please tell Paul his presentation was fantastic and the bit about pie brought on tears. Beautiful and elegance are not enough. So I have to tell you that, Paul.
Yeah, thanks. Thanks, Professor.
It wasn't the first time to be outvoted, Evelyn. Oh, I'm sorry. Miro, 4 doesn't work here. Yous are just itching for wait until I get back on my own channel.
There's always one.
Yeah, but they're just itching to wait. Because every time I'm on a chat somewhere else or whatever, they'll put 4 in it. Are 2 quicks equal to 4 Mars? I don't know, Dora. That's a good question. Okay, I'll minimise that. Get that out of the road. Oh shit, sorry. What did Miro say I'm sorry about? Did I miss something? Oh, 4. Now wait till next week, I think. I've only got a week to go before I go back to live on the 19th. And I still haven't thought of a name for that show. So any suggestions from the Peanuts for a title for next week's show? It won't be formatted as much like we do now, because it'll be just my first one back. So it'll just be a free-for-all, and hopefully I can get some surprise guests to come on, which would be good. And I might even start streaming if I get back live that day. If it's next Saturday, I'll actually stream earlier, like in our daytime, in our afternoon, and I'll make it go for about 10 hours or something. You know, just let people come and go.
So Terry, are you saying that you're planning it to be more unplanned than these ones?
Yeah, you could put it that way, yeah. But don't let anyone know that I've planned it.
Yeah, that's the plan.
Yeah, that's the plan, yeah. There we go. Hello, wonderful person.
Hello, wonderful person. This is Anton, and welcome back to Mars, the most mysterious planet as of 2019. The planet has been trending quite a lot, actually. Now, today we're going to be talking about a relatively recent discovery of an absolutely gorgeous asteroid crater that was actually discovered last year, but didn't really make it into the publications or into the news until just a few weeks ago. This crater was actually created in the actual polar cap, and that's what makes it absolutely gorgeous. Now let me actually show it to you first, because the actual photo itself will probably do all the talking. So this is what it kind of looks like in black and white, although once you saturate it with color, it looks much more interesting. So here is what it might look like in actual real color. As you can see, it's essentially the polar cap that was kind of freed by this meteorite or asteroid that hit the planet right there. The actual size of this is just around 1 kilometer in diameter, suggesting of course that this collision was pretty powerful, and the actual power of the collision can be witnessed from the effects around the polar ice. Now there's actually two main colorations here, and they kind of show the two different effects of the collision. The lighter color that you see kind of around the ice, that's most likely from the actual shock wave that was generated from this collision. And the darker color patches are from all of the dirt that was excavated by the meteorite or by the asteroid when it collided with the planet, and when all of this kind of dirt just exploded all over the place. And interestingly, obviously this also went through the ice cap, exposing the actual dirt underneath. And this is kind of what probably happened to Greenland craters that we discovered just very recently and also a few months ago. This is probably kind of what may have occurred, except on a much larger scale, because those craters were, I think, about 20 times larger than what we have here. But Mars is actually a pretty exciting place to study because there's a lot of craters here. As a matter of fact, if you were to try to count them, which someone actually did for their PhD, although not really by literally counting each one, but by counting a little bit and then trying to make a general assumption about how many there were, there is going to be close to 1 million actually relatively large craters. If you were to look at the specific size, there's about 43,000 craters that are about 5 kilometers or more in diameter, and that is huge. These are like huge impacts we're talking about. At the same time, if you were to look at the craters similar to this, so about 1 kilometer, you would actually find over 385,000 of these craters. So these are pretty common. Now on Earth, we only are aware of about 120 craters. So can you guess why? What's the discrepancy here? Does Mars just have more collisions? Well, in some sense it actually does, because it is closer to the asteroid belt, but the biggest difference of course is that Mars has lost its atmosphere and most of its geological activity, which we don't think exists here anymore, although there is a paper that kind of suggests otherwise, but that's another story. Mars basically has no way of getting rid of these craters. Once they happen, they stay there for billions of years. Earth, however, probably had more. If you were to actually count the amount of craters it had, and if they did not disappear, you would have a lot more, simply based on what we see on the moon, because the moon actually has just as many as Mars does, but moon is smaller in size. So the actual effects of Earth atmosphere and geological activity allow Earth to basically kind of clean itself a little bit and remain spotless. Now, I wanted to actually talk a little bit more about Martian craters, because Mars has a lot of records, and one of those records is for the biggest actual confirmed crater in our solar system. So Mars is basically that record holder for what may have been the largest collision from an asteroid, not from a planetary collision, but from an actual asteroid. And it's actually a little bit challenging to find it here, because it doesn't actually look like an actual crater, what you imagine a crater to be. But I'm going to try my best. Actually, to try my best, I'm going to cheat a little bit and use Wikipedia, because it does have a really cool map that you see here. Let me actually move it a little bit. That points out the major sort of locations on Mars. But what we're looking for is this. This is called Utopia Planitia, which basically refers to as a plane of wonderful paradise, technically. Utopia is supposed to be this wonderful place. But Utopia Planitia is a confirmed crater. It's right here, and we can try to locate it on the model of Mars in Universe Sandbox by looking for those triple volcanoes, which are, there you go, there they are. So this right here, let me actually pause this for a second. This area right here is a very large crater. This is literally the largest crater in the solar system. This kind of takes up pretty much about 50% of Martian diameter, and in terms of the diameter from one end to another, it's about 3,300 kilometers. Now that is huge. That's basically the size of a country. The type of a collision that may have caused this would be with basically an object similar to like Vesta, a very, very, very large asteroid. So let me actually place Vesta here for a comparison, just so you can see what could have caused this. This is an object that's about, what is it, like 280, 270 kilometers in radius. And this would have been enough to cause the collision. Let's actually maybe try to simulate this by doing the following. By making it slowly crash onto the Martian surface, as it also gets influenced by the Martian tidal effects. And there you go. So this would have caused that crater. That would have may have created something that looks like this. It could have even been larger, as you can see. But that's not actually the most exciting crater on Mars, because it has another really cool crater. As a matter of fact, the most visible crater in the solar system that literally looks like a crater. And oh wait, did I? No, I thought I accidentally crashed it into that crater. There it is. It's very, very easy to see. This is called, as you can see from the map, Hellas Planitia. And the exciting thing about the Hellas Planitia crater is that it's actually extremely deep. It's about 7 kilometers in depth. And for this reason, the air pressure in this crater is actually higher than air pressure anywhere else on Mars. And this is, for scientists at least, a very exciting place to study, because here, at least during the summer, the temperature can be above zero, and it can actually form liquid water, at least if it's salty enough. So basically, the conditions inside this crater, in the depths of this crater, are enough to create a kind of a state of water known as the triple state, where it can be both gas, liquid, and also ice at the same time. So yeah, basically here we can technically find liquid water in the depths, because the actual pressure is just a little bit higher. And in terms of the actual size, this is about 2,300 kilometers. So it's about 1,000 kilometers smaller than the Utopia Planitia. But nevertheless, a really, really awesome place, and definitely an interesting place for us to land in one day, possibly even for a human colony, because we do expect to find some potential water there. But there's also, interestingly, a lot of underground water in Utopia Planitia. As a matter of fact, there's a huge amount of ice water, with potentially as much water there as Lake Superior in the United States. So definitely a very exciting place, or technically United States and Canada, because it does kind of border both. But yeah, very, very exciting place to land here, or here if we want a little bit more air pressure. And both of these are definitely going to be some of the future locations for a potential human settlement. Now, there are definitely still quite a lot of things to learn about Mars, and for us as future explorers of this planet, there's definitely a lot of places for us to kind of maybe consider for a potential landing or even a settlement. For now though, I guess all I wanted to show you in this video is the, well, record for the biggest crater in the solar system, and also the record for the deepest crater in the solar system, both of which are pretty exciting. But all of this started with this beautiful image that was released by NASA only a few days ago. Anyway, on that note, thank you so much for watching. Hopefully you know a little bit more about Mars and the solar system in general. And if you've enjoyed this video, don't forget to subscribe, maybe even like this video, and share it with someone who you think may want to know more about Mars. Come back tomorrow to learn something you may have not known before, and also maybe potentially consider supporting this channel on Patreon. It does help me quite a lot. On that note though, I'm going to definitely talk more about Mars, and specifically some of the future Martian missions, in one of the future videos coming maybe in the next few weeks. For now though, that's it. Mars is a pretty awesome place. Let's try to get there in the next few decades. Space out, and as always, bye bye.
There you go. Hey Wally. Did you drop something I thought I seen? Or did I? Wasn't my imagination, was it? If you want to duck into Discord after this, Phil, I can explain it to you better over there. It's pretty easy to find out. How long have we been going for? 2.5 hours. Got time. No, that's Wolfie's one. Mr. Sensible, no. Simon, Jose, Planer. Right, I couldn't see one for now. Can we send the flirts first? They may be able to fertilise Mars. You mean the bodies or their waste? We'll finish off with the Pip story and then we'll end up over on Discord for a little while. So, where are we? Get rid of that. So, finish off with the Pip story. If we send the flirts there, how would they survive though? Alright, what have we got here? There you go, there's your Pip story for the night. They wouldn't survive, that's the part.
The Inappropriate Children's Guide to Deities, Demigods and Demons. Deities, demigods and demons. A definition. How do deities and demigods differ? A deity is a god or a goddess who is thought of as holy or divine. A deity may or not be supernatural, although supernatural deities are more common and more fun. A demigod is a post or transhuman god. You can become a demigod after you die with the help of other deities. You may be a demigod right off the bat if you're born to one or more parents who are deities. You may slip to demigod status if you're a deity who's relegated to the minor leagues, because mortals have stopped singing songs of your triumphs. Demons are also supernatural beings. Demons may be fallen angels, possessed humans, or human corpses, or some nebulous spirit that's gone bad. Gaia is a Greek primordial deity. She is the mother goddess, having given birth to the earth and universe, as well as the Olympians and other giant gods. In modern times she's come to represent the enclosed, connected ecosystem of the planet. If you injure the planet, you injure Gaia. The trouble is, she doesn't give a shit. Wipe out 100,000 species and life springs up between the cracks and crevices, even more beautifully weird than before. Frack the stones out of a peaceful valley. Whatever. She'll just fold the tectonic plate, thrust up a new mountain, and turn a verdant sea into a spiny desert. Does she shed a tear when a baby panda chokes to death in a bamboo shoot? Hell no. She's content to watch every creature on earth attempt to eat its neighbour alive. Even herbivores eat meat when they have the chance. So break out the DDT, saccharin the surplus nuclear arsenal. The flatworms, amoeba and nematodes will have a feast on your bones soon enough. Kali is a Hindu goddess of time, creation and destruction. Mainly destruction. She loves destroying armies and cutting people's heads off. During a heated battle with evil forces, she was born out of the goddess Durga, mother of the universe, see Gaia. Top god Lord Shiva had to step in and stop her from killing everyone willy-nilly. Despite this, she's often considered the divine mother. And you thought your mother was difficult. Kali is generally portrayed with her tongue stuck out, which means, in a lovingly disapproving way, that you're wasting your time with your silly art project, garbage band, or poetry slam. Jesus Christ, aka Jesus of Nazareth, is the central figure of Christianity and is considered the Son of the Creator God and one manifestation of the Holy Trinity. Jesus falls into that awkward cultural milieu where many consider him an historical person who literally experienced the events of the Bible's New Testament, while many others consider him a metaphorical construct with little, if any, historical reality. Either way, he's cool with it. He was crucified on a cross, entombed and rose 3 days later. Not an easy way to die for your sins. What you do with that is up to you. It's your free will, and that's what all the fuss is about. Lilith was, in Jewish tradition, Adam's first wife way before Eve. Truly unequal, she was created at the same time as Adam, and not from some spare part like a rib. She split, however, when Adam requested that she be more subservient. As the world's first feminist, she's often portrayed as a demon that hangs out with snakes and has ugly bird feet. Probably a lesson in there somewhere. Venus is the Roman goddess of love, beauty, prosperity and desire. Don't bother reading any further. She won't talk to you. Achilles is a Greek personification of eternal night and the darkness before creation. She's often used to represent misery and sadness, and may be pictured as dishevelled and pale with swollen knees. She is no fun at parties. If you're lucky, she'll wash your car windows for $1. Eris is a Greek god of strife and discord. So unpleasant was she that she was snubbed at the wedding of Peleus and Thetis, future parents of Achilles. As revenge, she tossed a golden apple into the wedding party with the inscription, "To the fairest one." This promptly led to a fight amongst the bridesmaids, each of whom thought they were the most beautiful and sophisticated. Top god Zeus demanded a judgment of Paris' beauty pageant, where Paris, Prince of Troy, awarded the apple to Aphrodite, and doomed his city to destruction. No win situation there. The moral of the story is, if you're immortal, you're pretty much fucked. Letitia is the Roman goddess of happiness and joy. Not much is known about her. People don't see her around as much as they should. Medusa was, flat out, a Greek monster or gorgon. Terrible as she was somebody's daughter. Poor parents. Then again, her parents were a 100-headed dragon and a half-woman, half-snake, so they should have seen that coming. Technically, she was not a demigod, but was mortal. She certainly was demon-like. As most of you know, she dug turning people into stone. You'd be angry too if your hair was replaced by a slithering mass of snakes. She's sometimes used to represent nihilistic ideals, such as, everything sucks and then you die. At least she got some quick relief when Perseus cut her head off. After all, we can't all be born beautiful. Strigoi are, in Romanian folklore, Romanian, not Roman, poltergeists that can take animal form or simply stay invisible in an attempt to suck your blood. Strigoi more are even worse, whereby demonic spirits take over a corpse and claw their way out of a grave. Despite the depictions in popular culture, blood-sucking undead are really never that sexy. Undead supermodels are rare. You're more likely to get a naked, rotting fat guy with swamp gas flatulence going after your neck. The wood nymph, also known as a tree nymph or hamadryad in Greek, is a spirit that lives in a particular tree. It's not clear whether the tree nymph is a spirit bonded to a tree, is the plant spirit of the tree itself, or is a type of dryad, which is a minor goddess specialising in forest conservation. Regardless, when you cut down a tree without appeasing the nymph, you kill the nymph. Unless lumberjacks have been making ritualistic sacrifices, modern man has propagated a supernatural genocide of epic proportions. Thank Durga you're reading this as an e-book. However, think heavily before unspooling the next roll of toilet paper. Santa Muerte translates to Holy Death. Nuestra Senora de la Santa Muerte has her own Catholic spin-off cult. Although scary as an ornately adorned skeleton, she helps the dead safely cross over to the afterlife. She likes shrines and will occasionally grant wishes to the poor and needy. Santa Muerte is less of a bummer than the Grim Reaper, who is also a personification of death. Grim Reaper comes from the medieval English folklore. Many people have tried to trick, defeat and bribe the Reaper with no success. Of the two, I take my chances with Santa Muerte. At least she doesn't carry a large rusty cutting implement. Kitsune. Not all demigods and deities are Greek, Roman, Christian or Hindu. Many other cultures have a rich pantheon of suprahuman beings. For example, kitsune is a Japanese word for fox. Folkloric stories from Japan depict foxes as magical beings, which are able to possess human bodies and shapeshift into human form. Although considered wise, kitsune are notorious tricksters, and will seduce farmers' wives and young bachelors, steal food, humiliate the boastful, and seek revenge on those they just don't like. Sure, they look cute, but have you ever seen a fox rip into a carcass? Okay, they are pretty cute, even when covered in blood, viscera and offal. Damn you, Gaia. Oh dear, I apologise for my pronunciation of this. Mbaba, or Mbaba Mwana Maresa to be formal, is a South African Zulu goddess of fertility, rain and beer. She lives in a rainbow house in the sky with her true love. Pretty neat. The end. Don't forget to like and subscribe, and hit the wee bell notification. Thank you to all my wonderful subscribers and patrons. See you next week. Bye bye.
Bye.
You have to love Pip's sense of humour.
I'm sure one of those demigods or whatever picture looked exactly like Lilith out of the Munsters.
Or God, what's her name from the Addams family? Morticia.
Yeah. No, that's
Morticia, yeah.
Morticia's out of Adams, but there was Lilith out of the Munsters. That
Yeah.
one. That picture. There we go. That one. Whoop. That one, yeah. That's exact replica. Yeah, that's out of the Munsters. That was a good show, that.
I have to say, for a woman with such a heavy Scottish accent, she does pretty well at the pronunciations.
Yeah. They're pretty good. Blue, what are you spamming for out there for?
Settle down, Mark.
Got another week to go yet, Blue. You're pushing it. Yeah, Phil found it. I stumbled on it. 22nd of September is my get out of jail. Yeah, it only lasts. It lasts for 3 months. So September, the end of this month. Okay, so you've already gone a couple of months. Oh, well, that's your lot for the night. I haven't seen Alan tonight, so don't ask me where he is. I'll hear all about it later, what happened, what he was up to. Which I have to thank him, and he's not here to thank, but there's a word for that if you're thanking somebody that's not here. That's just my old brain not remembering these words. Posthumously or something?
No, he's not
that's
dead,
for somebody
Terry.
that's dead.
He's not dead.
Okay. I don't know. I'm trying to think of the word.
Settle down.
I know there's a word for it when someone's not around when you're thanking them for something.
Oh dear. In absentia.
I'll send him a good well card.
Yeah.
I knew when I said it what that meant. I'd get a laugh out of it. But yeah.
It's like that, but when they're not dead.
Oh dear. Yeah, okay.
Well, at least he'd have a good excuse for not being here.
Yes, that would be a good excuse. I haven't heard that one before. Oh, I was dead.
Yeah.
Oh, sorry. Okay.
Yeah.
Didn't know. I apologise.
I got better.
You got better. Okay. Oh, well, thanks, Darlin, anyway. Thanks, John. Thanks, Monk. Thanks, Robert Milliken. Did we get the story from Robert
Yeah.
Milliken, what he was?
He was the one that measured the charge on the electron. So
Oh, did
he
he?
was pretty
Good man.
famous for that.
Oh,
Yeah.
Okay. Oh, thanks to him. Thanks to... Oh, look, Matt come in late. Jeez, Matt, you're a bit late. And Blue, you came in and then went back out again, so I don't know what happened there. No
Matt,
name.
okay, the casual sadomasochist.
No name. Zebulon, Phil. Thank God it's flat. Good to see you again, mate. Dora. Mira, Hads. Scrolling. Who else have I missed? Demon Orb. Professor Pineapple. Dora, Zebulon, Hads, John. Just the usual suspects, by the... Oh, the Elmigs. Didn't see them there.
Oh, casual popped up.
Yeah, a bit late, mate. We're going over to Discord in a minute. Oh, Peter was out there. Okay, who have I missed? Quick, you got 2 seconds to type your name if I've missed you. No, I got you, Mira. I got you, Demon.
Hey, Damon.
Zoom doesn't like you today. That's a shame, Blue. That's okay. Oh, if anyone comes over to Discord, you're more than welcome. If you haven't got the link for Discord and you want to come over, I was going to say tough shit, but I can't say that. You'd have to work out a way you can get through to me, or I can get through to you on Discord to send you the link. Okay. All right then.
And don't forget, folks, it only costs $1 to do science to prove the Earth's flat.
Oh yes. Depending on where you are.
Yeah.
All right. Good night, guys.
Night all.
Good night.
Good night, Brosimum alacastrums.
You tried hard to pronounce
Whoa.
that then, didn't you?
I have to resort to scientific names now.
Oh yes. That one did sound scientific.